Hello, and for today's problem, we're going to be doing 167 to some 2 input arrays sorted. Okay, so given a 1-indexed arrays of integers numbers that are sorted in a non-decreasing order, you want to find two numbers such that they add up to a specific target number. We want to let these two numbers be numbers index 1 and numbers index 2, where 1 is less than or equal to the index 1, which is less than index 2, which is less than the length. Okay, that makes sense. So we want to turn the indices of the two numbers added by 1 as an integer array of length 2. Okay, and we want to make sure that there's exactly one solution. You can't use the same element twice, and the solution must only use constant extra space. Okay, so right off the bat, like a solution, not really a solution, but an idea for this would be to do use a hash map in order to store the complements of the values and then do it in that sort of way. But the problem with that one is that the space complexity would be O of n, because if we similar to the two-sum problem, without a sorted array, if you were to just store the complements in a hash map, then the space complexity would be O of n, because in the worst case you'd be storing every single number. So okay, let's think. Okay, so a way to do it using only constant extra space. Okay, let's run through an example. We have numbers 2, 7, 11, 15. We want to return 1 and 2 because the target value is 9. Okay, a way to do it would be, since we know that the array is sorted in non-decreasing order, we know that every single element after, like say for 7, every single element after this is greater, and every single element less than is non-decreasing, so it can be either the same or less. Okay, we can utilize this by having two pointers. So we have a pointer at the very last element in the array, and we have a pointer at the very first element in the array. Let me just copy this for an example. We want to have two pointers here, and then what we can do in order to find the value is we can add these up together. We know the target for this case is 9, and we want to see if it equals 9. So 15 plus 2 obviously isn't 9, it's 17. But we do know that 17 is greater than 9, and since we know that it's the array sorted in non-decreasing order, what we can do is we can then decrease the amounts. We can decrease the amount by moving the right pointer by to the left by 1. Doing so, what it does is actually decrease the amount. So we have 11 plus 2, that's 13. It's still greater than 9. We can move it again, and then we have this 7 plus 2, that's 9, and that's where we have our final answer. So okay, so just trying to think of this should work. So the first thing we can do, if I can code this out, is we have the left and the right pointer starting at 0, and we have that at length. We have and we want to keep the right pointer at the very end, so then we have length of the numbers array minus 1 because it's 0 indexed. Okay, so okay, just to make sure this is efficient enough, the time complexity of this one would be, in the worst case, in the worst case, it would be 2n, because actually, okay. For this two pointer, in the worst case, it would be over 2n, because you're at 15. you decrease it by 1, you increase this by 1, and eventually we know like it'll reach like the value you need. We know there's exactly one solution, so like we know like all there has to be like one solution for every single array. So this should be O of n, because it'll stop like in the worst case it'll have to iterate through every single element in the array with the left and the right pointer. So yeah, this should be an O of n solution. And then the space complexity for this one would be O of 1, because you're not actually storing any elements in memory. You're just moving the pointers left and right. So those are the only things you're storing, and it's static. Okay, yeah, just wanted to make sure that like it matched the criteria of the constant texture space. Okay, so to continue coding this up again, we want to loop through while left is less than the right. Yeah, like that should always be true. What we want to do is we want to check to see what the current value is. Well, the value of the left plus the right added up together is. So we can do like the val is equal to numbers left plus numbers right. Okay. Now that we have this, we can check to see if the value is less than the target, then we want to move the left pointer up forward to make it greater. Otherwise, if val is greater than target, we want to decrease it by moving the right pointer like by 1. So moving the right pointer back by 1, what it does is decrease the total value, and moving the left pointer up by 1 increase the total value. So we'll do that. And then if it matches, what we're going to want to do then, if val equals the target, we're going to want to return left and right, because the first one okay, yeah, so the first one has to be less than, and the second one has to be greater than, so we do left and right here, and then we want to add it by 1 because that's the criteria over here, and then return that value. Okay, so just to walk this through again one more time, we have 2, 7, 11, 1, 5. Okay, let's use another example this time. We have 2, 3, 4. We have a pointer starting at here and a pointer over here, left and right. What we do is we check to see what 4 plus 2 is. Oh, that's 6, so it's automatically matched. We're good. Okay, we can just use this example again. We have 15 and 2, add that up, 17, subtract, like remove this here, 11 plus 2, 13, 7 plus 9, 9, and then return that over here, add added by 1, because it's 1 indexed. Okay, so everything looks good here. Let's go ahead and test this out by submitting it. Okay, it's good. Nice. Okay, well, thanks for watching.